Chain of thought prompting is a technique where we ask an LLM to generate intermediate logical steps. For any user question, instead of directly giving the final response, we want LLM to break the problem into smaller steps. In this example, we will ask LLM to generate the subsequent reasoning steps before calculating the final price of the product. The first step is to calculate the discount amount. The second step is to subtract the discount amount from the original price. And in final step, it will calculate the final price. So instead of simply going from input to the final answer, chain of thought breaks the problem into intermediate reasoning steps. First, calculating the discount, second, subtracting it from the original price, and finally arriving at the answer. Let's understand key benefits of chain of thought prompting technique. First, it can improve the accuracy of an LLM on complex problems, especially when the task involves calculations, logic, or multiple decisions. Second, it makes the final answer easier to debug and validate because we can examine the individual steps and identify where the reasoning went wrong. Finally, this approach is particularly useful in production systems where the reasoning process can be divided into structured stages and each stage can be verified before the next one begins, making the overall system more reliable and easier to control. Now we will do a quick practical demo of chain of thought prompting technique. We are going to use LangChain framework for this. Take a small reasoning problem and run it through two different prompt structure. Then we will compare the results and see whether that extra reasoning structure actually makes a difference. So let's start with the problem we are going to give the model. We have four developers A, B, C, and D, and four projects P1, P2, P3, P4. Each developer has a few constraints on which project they can work on. The goal is simply to find a valid assignment that satisfies all these rules. So, in the first approach, we simply ask the model to solve the problem directly without giving it any reasoning structure. And as you can see from the output, it gets the answer wrong. It assigns D to P3, even though the problem clearly says D must work on project P1. Now let's look at our second approach where instead of asking the model to solve everything in one go, we will structure the prompt into multiple steps. First, we will extract all the constraints from the problem. Then a second prompt will analyze those constraints and work out the solution. The third prompt will generate the final answer and a fourth prompt will validate that answer against all the constraints. If the validation fails, we will send the feedback back to the generation step, generate a correct answer and validate it again. So instead of relying on one prompt to do everything, we are creating a small reasoning and validation pipeline. Now let's look at the output from each of the structured steps one by one. And with this structured approach, we got the correct final answer on the first attempt. We didn't even need to trigger the feedback and correction loop. I have added the GitHub link to the code in the description, so feel free to have a look and try it yourself. If you found this useful, don't forget to like the video and subscribe the channel. Thanks for watching.